what's up guys, Pete here, and welcome back to Proto Productions. It has been an absolute whirlwind couple of months for me as I flew the Universal Test Machine behind me all the way out to San Francisco, California to showcase it live in front of tens of thousands of people for OpenSauce. Now in this video I am going to go through some updates on the actual test machine itself as far as what I had to do to get it ready for the show and what's still waiting for it now in the future. But before we do any of that, I really have to give you guys a rundown of just what a wild event OpenSauce was and just how awesome it was to be able to showcase this machine to all of you guys in person. The event was hosted to over 50,000 people over the course of the weekend, and trust me, it felt like it. I was manning the booth for basically the entire weekend, which unfortunately meant that I basically missed actually getting to experience the event itself, but I would say it was totally worth it for getting to see all of you guys in person and show off the machine. Over the course of the weekend, I spoke to literally hundreds of people about this project, from all walks of life, all backgrounds, and it was just so incredibly rewarding and eye-opening to get to share this project with so many people. Dozens of you that came up actually have backgrounds in material science, either working in testing labs currently or working adjacent to them, and getting to see your genuine excitement about this project was just so wholesome and rewarding after all these many months of hard work. I really can't put into words just how incredible it felt to get to share this experience with all of you guys and see your genuine reactions to it in person. For anybody who actually stopped by the booth, I cannot thank you enough for taking the time out of your busy weekend to come and see my project and my booth. That meant the world to me, and it was awesome to get to explain the whole project, and for the few that were really interested in it, to get to see your eyes light up at the prospect of this project. Several of the people that I met that weekend were either currently trying to build their own test machines for their own purposes, or were excited enough after seeing this project to want to try and build their own. And I cannot put into words how perfectly that encapsulates what the whole goal of this project was: to inspire other people to have the tools to start building their own test devices and start collecting their own data. The machine itself also did an incredible job of holding up to its first live event and really its first real torture test. We were pulling tensile specimens the entire weekend. I must have gone through probably 100 different specimens throughout that time, and throughout the entire process, the only thing that broke were the off-the-shelf tensile jaws that I bought off Amazon. And even then, we were still able to do tests thanks to a little creativity and a little brute force. There were, of course, some software bugs and glitches throughout the weekend as well, but honestly, considering how last minute a lot of this stuff was thrown together, I couldn't be happier with the overall performance of the machine and just how well it all kind of worked together throughout the event. It was also an incredible learning opportunity where I got to kind of push the machine to its limits and find some of those areas that definitely need some improvement. And of course, it was also a great chance to just talk to you guys and get genuine, just live feedback about the machine. What features you might be looking for, what aspects of it you think might need to be changed in one way or another to make it more accessible. It was genuinely really eye-opening and just an awesome time to have that dialogue about this project that I've been working on alone for all these months and finally get to just talk with people about it and see what you think about it. One question that I got a surprising amount was, are you selling kits and where can I buy one? I've mentioned before that this was something that was kind of on the roadmap, but I was genuinely surprised to see how many people were interested in going that route, which I guess in hindsight actually kind of makes sense. If you're an educator, your time is really valuable, and so spending it physically having to source all these parts is not the best use of your time. Whereas if you can just buy an off-the-shelf kit and then just have your students put it together, that's a much more reasonable thing to ask. So with that in mind, moving forward, I think I'm going to put a little more emphasis onto that mindset of, okay, this may need to be a kit that's kind of sourced together with that in mind. But unfortunately, at least for right now, you are going to have to source the parts yourself and build it on your own. With that being said though, hop in the Discord. We have a great growing community over there to help with a couple of people that are already trying to build their own tensile testers. So if it's an avenue you're looking at exploring, hop onto the Discord and we'll help you on that journey. For any of you guys that are watching that I happen to have the pleasure of meeting at the show, again, I just want to thank you so much for taking the time out of your busy weekend to stop by the booth. It meant the world to me to get to hear your stories and just share this project with you. So thank you again for stopping by, and I hope you're along for the ride for the rest of the series. All right, with the OpenSauce portion of the video out of the way, let's actually head over to the bench now and talk a bit about what it took to get the machine showtime ready, what decisions I had to make and what pivots I had to do last minute, and then where the machine is actually going to be going from here as far as general design changes and just kind of project scope in general, because there were a lot of lessons and takeaways from that weekend that are definitely going to influence where we go with this project next. In the last video, I already kind of teased some of the changes that we made to this guy leading up to the show, but now we're actually going to dive in a little bit deeper. The first and most obvious big change that we have on this machine is that it has an enclosure now. Previously, the last time that you guys saw it actually during the assembly and testing stages, it was just a bare bones kind of naked machine. And while that's great for an initial prototype machine where you're doing a lot of testing and iterating, it's not great for a live demo where you have kids that might be putting their hands where they don't belong. Going to a live event like that pretty much necessitated having an enclosure, But I'll be honest, pretty much everything about this enclosure is not great and makes the overall experience of using the machine also not great, even if it does look aesthetically kind of nice, at least in my opinion. The current enclosure consists of 4 main pieces. You have these 2 identical side pieces here, bent out of 3mm thick aluminum, and then we also have a front panel and a back panel here that are made out of polycarbonate. And like I said, pretty much all of this is no bueno as far as like the final version of this enclosure. The first big thing I would change is that these side panels here that are made out of bent aluminum, that's way overkill. There's no reason to have done that. This was a classic case of when all you have is a hammer, everything starts looking like a nail. Oshcut very kindly sponsored all of the exhibitors at the event, and so I had access to basically free to me sheet metal fabrication, and so that's what I went with. But obviously, there's no reason for these to be made of metal. These are not structural in any way, shape, or form. They are just there for guarding and shielding, and they could be literally pieces of paper if they needed to be. The choice of polycarbonate for the front and back doors here is probably fine. We can probably keep that, but the overall design of them, from the hinges that I chose to attempting to use these little magnetic latches to the very last minute addition of a weird little back side latch to keep the door closed, pretty much all that's got to go. So I need to redesign pretty much every aspect of the enclosure. The other big thing that I found out while playing around with this and using it for 2 straight days is that the access in here is actually really limited, especially with how my doors are designed currently. Trying to reach to the backside here to actually install specimens and try to, pivot your clamps, it's just a nightmare as far as ergonomics and access. So there's a lot of changes that need to happen here. And while we're talking about the clamps in here, let's actually talk about the only part that mechanically failed throughout the actual event. These 2 little jaws are just off-the-shelf Amazon tensile jaws that I found. I was originally using these guys right here, but these just didn't bite strong enough for the materials that I was testing. I then found these guys, which are plenty robust enough for at least basic PLAs, but man, their longevity on them is not great. In this case, both of these ended up failing before the end of the weekend, and the issue is actually the screw that's used to tighten this jaw right here actually sheared off in both cases. Now, we were still able to use it throughout the event by just having it pushed directly on the jaw, but normally this screw actually lives inside of the jaw and is retained in there so you can pull the jaw back and forth. But unfortunately, the way that it was assembled was pretty wimpy, and we did end up shearing both of them off before the end of the event. This is going to be an issue that I have to solve at some point. I'm not entirely sure how I want to address this because, again, trying to fabricate your own jaws that are going to hold up to the forces that we need are going to get a little complicated and a little expensive, but these are the best jaws that I've found so far that are like commercial off the shelf you can just buy off Amazon. And even then, they're still pretty flawed. So this is definitely an area where we're going to have to dig in a little bit deeper and really try to solve the core engineering problems we have with these types of jaws. I did have a really good discussion with one of the guys that came by the booth, though, talking about the proper style of tensile jaws where you have the wedge-style grips, and some options for getting those fabricated out of slightly more affordable options like laser cutting or water jet. So keep an eye out for some of those types of changes in the future. The next big change is on the electronics and the control side of things. If you guys will remember from way back when, we initially started with this wonderful little breadboard that frankly did everything it needed to do, just in a very inelegant package. Since then, I've actually gone through 2 separate iterations of different PCBs. This is the first one that I made, and when I say the first one I made, I mean literally this is the first PCB I have ever designed and fabricated in my entire life. The learning curve was rough, and as one would expect, that design was not great. So now there is a V0.2, which is a completely redesigned board, although with pretty much all the exact same components on it, and this is what's actually inside of this little control box right here. Now, the control board's main purpose is just to kind of shield the electronics while giving you easier access to some of these switches here without having to actually like poke on the board itself, so a little bit safer for an event like this. The only physical buttons you have for control of the machine is just the jogging of the crosshead up and down, enabling or disabling the motor, and of course a nice big red e-stop button. Which, yes, I know, it doesn't latch, I apologize, it is purely a software e-stop. We'll work on that in the future because this is just not very satisfying. The new design of the board is also set up such that all of the connections are on the back side right here, so it makes cable routing a little bit neater. That being said, you do still end up having to plug in your power and your USB to your computer on the front side here, so it's not quite as clean as I'd like it, but it's a pretty good starting point. And unfortunately, as early hardware projects tend to go, all of the work that I've done here is very soon going to be completely outdated and scrapped because unfortunately, I'm rapidly running out of headroom on the Arduinos that I'm using to actually control this machine, and I'm probably going to switch over to something like a Teensy, just a much more capable MCU. And while that's great for the project as a whole, it does mean that pretty much all of this needs to be re-architected and redesigned from scratch. But at least I've already learned how to do the basics of the PCB design, so hopefully Rev 347 will be a little bit easier. So that's it for the hardware side of the electronics. Let's actually look at what is probably the biggest change for this whole thing, which is actually the software that we have to run this whole machine. All right, this is our entirely vibe-coded GUI in all of its glory. I almost didn't bother to even build this before the show, but I'm so glad that I did. This was probably one of the most, if not the most, impactful thing that I could have added to the entire project. For the sake of the show, having a user interface like this that makes everything really clear and visual of what's actually happening during a test was just such a better teaching tool, especially for people who are less familiar with what they're looking at in the first place. So, high-level overview, we have a couple key regions on the screen here. Obviously, the most obvious, we have this wonderful plot right here in the middle that'll actually plot our stress-strain curves or our force and displacement curves, although you can toggle between those. We then have a couple of toolbars that allow you to either view the current settings of the machine or change those settings on the left-hand side here and in this middle section right here. And then at the bottom, we have our serial log where we can send and receive commands and just get kind of a heartbeat for the machine as we're connected to it. Right now, this is all kind of a hodgepodge of some legacy stuff from when I was issuing commands over the serial monitor back in the Arduino IDE, as well as some new concepts that I'm trying out for just kind of the GUI overall. So it's a little chaotic right now, but a lot of what's here I think is pretty important and will probably make its way into the final version of this as well. Let's just start working our way through the various regions here. Up in the top left, we have some of our primary controls for starting the different types of tests, and of course manually stopping those tests if we need to. We can also manually tear the load and zero out our displacement if we need to, although both of those things should happen automatically when you start a new test. We also have the ability to alter the various test and machine settings directly from the GUI. So for example, I can change my jog speed, my test speed, and the number of samples that I'm taking. So if I simply change my jog speed to 100 millimeters per second, or per minute in this case, and hit set, we'll see that update in the serial monitor down here, and the machine returns that ping to let us know that it's received that command. Fundamentally, our Arduino code is a state machine, and we can toggle between those states right here, and of course we'll be adding a few more as time goes on. You also get a live output of the load and displacement the machine is currently seeing, although right now these values are completely nonsense because I don't actually have any of those sensors plugged into the Arduino, so this is just software noise that you're seeing here. This first region that you see in this middle section is actually covering the results from a given test. So we get all of our numerical outputs for the various values that we're calculating, as well as information about what type of test parameters we were using, so we have that information for later. We also have some controls for the graph itself, so I can turn off and on things like the modulus line, the peak load reference, and our 2% yield line as well, which is just really useful for getting a visual of what the system is actually calculating in the back end, so you can look for any really erroneous readings when it's doing those calculations. I also added the ability to export and load in these data sets as CSVs so that you can save that data for later. Long term, this will definitely just be being stored in some type of database, but for now, this was a quick and easy way just to make sure I had a way of saving this data for later. And of course, I also added the option for exporting a screenshot because a picture's worth 1,000 words, and really this graph is what most people are looking for. Here you can actually see a bit of a bodge that I've had to build in, although it's actually pretty useful, so it might stay into this all the way to the final form. You see, the system is supposed to be able to detect when the test actually starts, the difference between us actually pulling on a specimen and us just kind of preloading the whole system. Unfortunately, it doesn't do a great job of trimming off those initial data points that aren't supposed to be used as part of the test data. So in cases like that, we added this little feature right here where you can manually exclude or include different data points so that if there's that, run up when you're pre-tensioning the jaws, or if there's just a random erroneous reading at some point during the test, you can just manually check it and make sure it's not included in the calculations or in the plotted results. So ideally, the software should be able to handle this for you automatically in the back end, but it is nice to have the option to manually clean up the data a bit if you need to. Now, to be able to actually calculate some of these values, the system needs to know the dimensions of our test samples, and that's what this middle section right here is for. Here's where we're able to tell it what type of test we plan on running, the general shape of our test sample, although right here I only have it limited to a few options right now. We'll eventually expand on that a bit. We get this poorly AI-generated graphic that tries to communicate what these different dimensions are, and then you can enter the numeric values for those different dimensions. And the nice thing is, if you want to, you can retroactively change these values and simply recalculate, and it will rerun all those numbers for all the values that it's calculating. Our last section here controls more about the actual test setup itself. Now at the very top here, we actually have a little bit of work left for me to do. Some of the values are actually hard-coded in the Arduino code right now, and you can't actually change them either from the terminal or from the GUI. So it's going to tell you what those values are, but you can't actually change these. This next section here is related to the automatic test stop detection. So this is where it's trying to see that the specimen has broken or failed in some way. And so it gives you some criteria for what percentage of load drop you're looking for, and over how many samples you're checking for that change. In my experience, at least for tensile testing, this works very effectively so long as you get a nice clean break of the material, but it can be a little tricky for more elastic materials. And this last section down here is what standard we're using to calculate our Young's modulus. You see, you don't actually use the entire linear region to calculate that line. Depending on what standard you're using, you're supposed to use a very specific region of it. And we have a couple examples of different ISO and ASTM standards here, and each one uses a slightly different range across this whole reading that it's supposed to use to calculate that line. You can see that, for example, the ISO 178, we go from 0.05% to 0.25% strain. Now, because of some nuance in how we're actually taking our displacement measurements, really narrow strain regions like this can actually lead to some pretty bad data as far as calculating that Young's modulus. So I've also added the ability to do a custom preset where you can enter whatever region or range you want to use to actually calculate that Young's modulus. And like I said before, on the bottom we just have our serial log here, so we can see kind of the heartbeat from the machine and any status updates that it sends us. And if you wanted to, you can also manually send those commands for things like changing your jog speed or test speed, etc. There are a couple other little nice to haves dotted throughout here. For example, you can change this graph from stress strain to displacement and force, just depending on what style graph you'd like to use. We also have the ability to kind of zoom in as well as auto fit the graph, which is, again, just nice little creature comforts. You can also change the units that you're in. So right now everything is in metric, but if I wanted to, I can switch this over to imperial units for my calculation, and I can separately change over to different units for my graph as well. While there's still a lot of work to be done on this in general, I'm still really happy with how this has come out so far. There's a lot of work to be done as far as little refinements and some bugginess here and there, but this still makes it feel a lot more like a real finished thing instead of this kind of cobbled together project. Besides just some graphical overhauls, some of the big things I want to change to this are things like adding a database backend so that we can properly store and catalog our results, the ability to do some type of statistical analysis on multiple tests that are supposed to be on the same material so you can get some statistical data for different sample sets. And it'd be great if this could all tie into some type of web front end where we can actually export this data directly to some website where everybody can upload and share their data. I'd also like to add the ability to compare different data points, because right now you can only display one graph at a time, but it'd be awesome to be able to overlay multiple different graphs so that you can get a sense for how different materials compare just visually by looking at the graph. Some of the core functionality stuff that I have in here is also going to change, but that's really because I'm going to change more about how the Arduino code works in the back end, and then the front end will update to reflect that. So overall, I'm actually really happy with where this is at today, but there's definitely some improvements I'll be making in the future. So where does that actually leave us with this machine and this project as a whole? What are the next steps? Well, I wish that were a simple answer, but unfortunately it gets a little complicated. Pretty much every subsystem of this machine could use some pretty major overhauls at this point. From the mechanics to the firmware to the software to the sensors, pretty much all of it needs some level of changes to get it to where I have the kind of vision for this project as a whole. Now, that being said, there are certainly some things that are more pressing than others. So, for example, mechanically, the structure here I'm actually very happy with. The motion system, the frame itself, it's able to deliver the loads we expect, it's able to do so rigidly and robustly, so we're probably not going to do any major changes to like the structural frame itself, but obviously things like the enclosure will need some changes. They're just a little bit lower priority for right now, because honestly, for my purposes, I'm going to strip all this enclosure off and we'll worry about that another day. On the other hand, something that is a little more pressing is actually how we're measuring our strain with this setup right now. Now, the DRO scale that I have in there is genuinely really powerful for what we're using it for, and it's giving us good data. But we are running into some practical limitations about such a budget option. Really, it's coming down to two key aspects of this particular DRO scale. One is the resolution that it reads in, and two is the fact that it reads in a finite, discretized resolution. First, let's talk about the kind of granularity issue that we're having. So we can measure down to like 0.02 millimeter granularity as far as the measurements that we can take. And while that sounds like a really small division, like that would work great for us, it's actually not as fine as you'd think. The issue you run into is that when you're actually trying to calculate your Young's modulus, for example, depending what specification you're using, they'll tell you what span across the elastic region you're supposed to use to actually calculate that straight line to find your Young's modulus. You don't actually use the full region. The problem with that is that they specify very narrow regions. We're talking like 0.05 strain to like 0.2 strain, which, believe it or not, on shorter specimens, depending on what your starting length is, that range might only be a handful of readings off of this DRO scale. So to combat that, I've had to do a little bit longer specimens than you typically would for these particular, I think it's an ISO specification that I'm using currently, but that is still kind of a workaround, so that's something we're going to have to address. The other issue that I'm running into is with the kind of discretized measurements that you get out of this DRO scale. It's a digital readout. It is not an analog value. And what that means is you only get hard, discrete values out of the system. It's either 0.02 or 0.04 or 0.06. You can't measure in between those. And the problem we run into is that when we're actually trying to take measurements with this system at, in this case, only I think 10 times a second, you might, especially for stiffer materials, have a case where for a single displacement measurement off that DRO, right, it's still at 0.02, it hasn't ticked over to 0.04 yet, I might actually take 3 or 4 readings in the span of that one tick mark. And my load cell is an analog device, so I get nice, clear, incremental improvements or incremental gains on that load that I'm reading, but I'm getting all of those readings with just one displacement value. So all of a sudden I have to decide what to do with all of those load measurements because I can only plot one load against one displacement. There's a couple ways you can handle this, right? You could average all the values you get for your loads. You could always take the highest value. You could always take the lowest value. It's a bunch of different strategies here, but all of them are a compromise in one way or another. Right now what I'm doing, I believe, is I'm averaging all those values. And the problem with that is you are inherently going to underreport the load for a given displacement. Because if you have an A, B, and a C value, right, C being the highest value, your average is always going to be smaller than the greatest value you ever saw. So I think right now what's happening is I'm actually underreporting my Young's modulus because of that averaging that I'm doing. So there's some stuff we can do in software and firmware to help with that a little bit, but really it is a fundamental limitation of the scale itself. And so we're going to have to look into some other options there. There are some really interesting options that we have, things like video extensometers, like how Stefan from CNC Kitchen is doing his universal test machine. We could also look at building a proper contact extensometer. There are some interesting ways we might be able to do that, but again, keeping it DIY friendly and budget friendly is going to be a little bit of a challenge. So there's definitely going to be some work happening there, but at least for right now, I think we're going to leave the scale as it is and just kind of understand those limitations for the time being. The other big thing we need to work on is the actual electronics controlling this whole system. From the fundamental firmware itself and just how rough that code is, to the actual microcontrollers that are actually handling this whole show, there's a lot of work to be done there to just refine everything, get it a little more robust and a little bit more user-friendly. What we have today works, and again, it held up more or less fine for those 2 days, but we definitely ran into some bugs and glitches throughout that time that a more robust software and firmware setup probably would have avoided. This becomes particularly important when some of those things are safety related. If the machine suddenly loses connection to the computer, you don't want to have this thing just running away and doing its own thing. You want to actually have full control over that machine in all of those failure states. So there's a lot of work to be done, especially on the safety side of things, before I'm comfortable kind of rolling out the software and firmware with this thing, which is why I haven't published any of that yet. Before I start digging too much into the firmware side of things, I will probably go in and overhaul the actual hardware on the electronic side first. Like I said, probably something like a Teensy or an ESP32, just a much more capable microcontroller that's able to handle all the overhead of the system as it stands today, just so that way I can add in some of those extra features that I need from a safety and a processing standpoint. If the Arduino is all the way, pretty much maxed out on what its capabilities are today, I can't add in all those extra features that I really want for this machine. And then of course we have the software side of things. Adding that GUI was probably the single most important thing that I did for the sake of the event. Being able to visually convey what was happening there was just such a better way of connecting with the audience and having them understand what's actually happening on this machine. Hands down, the single most impactful thing I could have done to help kind of round this thing out before the show. But even with that, it still has its flaws. And like I mentioned many, many times to everybody actually at the show, it's entirely vibe coded. So there is a lot of room for improvement there, especially from someone who knows actual programming much better than I do, which is basically not at all. So it's a low bar, but I'll take any help I can get. So if you're someone out there who is more gifted on the software side of things and you're interested in lending a hand, I would obviously greatly appreciate it. But either way, there is more work to be done on the software side of things, just again, to add additional functionality, to port some controls over and away from physical buttons here into the software as well, more automation, some additional safety features. There's just a ton of things that I'm going to add on the kind of needs-want list for that system overall. And hopefully over time and over a few iterations, we'll get a much more robust system from that whole package. What's up guys, it's Pete from the future here. Past Pete rambled for quite some time trying to explain this next part, so I'm going to try and do it just a little bit more concisely. What I wanted to say here was that there are a bunch of different groups that might want to use a system like this, but their requirements for it are pretty different. The people in the professional and semi-professional space care a lot about the actual values that come out of the system. They need to be accurate, repeatable, and reliable. For users in the educational or hobbyist side of things, the absolute numbers here are less important, and they care more about the overall experience and the ability to do this kind of comparative testing. While there is some kind of core common platform that will serve both groups generally, when we actually start trying to tailor what this machine can do and how well it performs, that's where we really need to know which group we're trying to focus on. Having a clearer idea of which group we're targeting makes it a lot easier for me to focus my time and efforts on this platform and make sure that it really targets a particular group effectively. That's all I was trying to say here. Not sure why Past Me decided to ramble for 10 minutes, but let's hand it back over to Past Pete. So let me know down in the comments, let me know in the Discord channel, where do you think makes the most sense for me to start focusing my effort on this? I have no problem kind of just shotgun approaching, doing little bits here and there and kind of dancing around, but obviously a more focused, targeted approach will be better for the project overall. So if I can have kind of a weather vane to kind of point me where you people think would make the most sense, that would be awesome. So let me know what you guys think, and we'll have a little open discussion about it in the comments down below and in the Discord channel about where we plan to go next. So that'll do it for the update on this guy as far as where we're at, what's next, and the incredible time that I had at OpenSauce. I do want to say one final thank you again. I know I've said it a bunch of times, but I really want to convey how awesome it was. Thank you to everybody who took time out of their schedules to stop by, see the booth for, in some cases, up to like 30, 40 minutes just chatting about the project and your own experiences with this kind of stuff. It was incredibly revitalizing, rewarding, and just awesomely heartwarming to see that type of community gather around these types of projects. So thank you again for stopping by. I really genuinely appreciated it. Look forward to future updates on this and new changes to this machine overall. As always, guys, thanks again for watching, and I'll see you in the next one.